All right, so there are two types. Two types of algebraic graphs. Two types of algebraic graphs. Two types of algebraic graphs. One type of graph is called continuous. The first type is called continuous. What does it mean if something continues?
Never ends.
It never ends, it goes on, right? What kind of shape would something that continues, what kind of graph do you think it would look like if it was continuing?
A line.
A line. Continuous graphs are connected. It's a line. If I was going to graph, now remember it's a relationship, right? So I have two things that I'm measuring. If I was going to measure my distance I cover over time, right? Every minute I would measure how far I am, my distance. I'd have time and I'd have distance. That would be my speed, right? If I was going to measure that, it's a connected line. Because in order for me to get from point A to point B, I have to cover everything in between. I can't teleport. Right? I'm connecting everything. It's a continuous, connected line, a line graph. The second type of graph is called discrete. A discrete graph is dotted or points. So we're looking at these ideas. We have to be able to determine, is this continuous, connected, or discrete, dotted? There are two types of graphs. So let's talk examples. Let's do a few little examples. Let's do our continuous one first. Let's do Julie slowly increases her speed. Then stops to rest. Next, she sprints home. So if we're talking about her distance from home, right? This is her jog, her exercise routine. She starts at her house and she ends at her house. I'm going to measure this with time and with distance. You have to think about your labels because there are two possible scenarios from this. You could do time and speed, or you could do time and distance from home. If I was going to do time and distance from home, if she slowly increased her speed, right? Then she stopped to rest. And then she sprinted home. If she starts at home and ends at home, that's what it looks like. But if I wanted to graph her speed, not her distance from home, my graph would look different. Do you agree? If I was going to graph her speed, it would look the same here. This would be the same, but then what would happen? It would go sharply up because I'm graphing her speed. If I was graphing her distance away from home, well, she's getting further away from home. She's staying the same distance, and then she's quickly getting closer to home. So it depends on what your labels are and what your graph looks like, what you're being asked to measure. But a continuous graph looks like this because Julie is covering every single piece of data. She's not in Harry Potter and just ends up in these locations. This is a continuous graph. Most of our graphs that we work with are continuous. But there could be discrete graphs, like Simon sells candles for $2 each. So if I wanted to make a graph to show the money that Simon is making, I would have my number of candles and I would have my money. And 1 candle, 2 candles, 3 candles. 1, 2, 3, 4, 5, 6, 7, 8. So if Simon sells 1 candle, how much money does Simon receive? $2, right? If Simon sells 2 candles, how much money does he receive? $4. If Simon sold 3 candles, how much money would he receive? Okay. If I went up to Simon at his little candle store and I said, "Hey Simon, I have $1.50. Can I get 1.75 candles?" No. Simon's going to say, "No, ma'am. You can get 0 candles because you do not have enough money for 1 candle." If I went up to Simon and I said, "Hey Simon, I have $5.99. Can you just shave off a little bit of that candle and I'll buy it?" He's going to say, "No, ma'am. Get out of my store." There is no way for Simon to make that in-between amount because you buy an entire whole candle. Right? So I'm not going to connect it. I'm not going to have data that lies between these 2 points. Because if I said, oh, you know what? My mom only wanted 2.2 candles for her birthday. He's going to say it doesn't work that way. Right? So we have small pieces of data that are not connected because this is continuous because every piece of data can be attained. This is not. This is discrete because all of this in between cannot be received. He cannot say, oh, you know what? Today I actually made $74.32. It is in increments of 2 because that's how much one candle costs. So you have to really kind of sometimes think about this. What would this graph look like? All right, so then we have writing relations. Or writing relationships. So you may be given the opposite. Instead of being given the story and having to create the graph, you may have the graph and have to create the story. You may have the graph and be asked to create the story. So if we're writing a relationship, the first thing we look to do is to break the graph into sections. Break the graph, split the graph into sections. And there are 3 basic types of sections. There are 3 types of sections. The graph could go up. The graph could go down. Or the graph could be flat. Those are the 3 basics. Now, within the graph going up, it could go up a little bit. It could go up a lot, right? I mean, there are different variations of it. But what are some words? If I had a graph that looked like this, here's an up, here's an up. What are some words you could use in your story to describe going up? Carly, what's one? Increase. Or increasing or increased, right? What are some other words that would mean going up? Accelerate. Oops. 1 L. Accelerate. Gain. What if it goes up like this? Not like this, but like this. What would be a word that would mean steeply skyrocket, right? Ascending, right? Those are all words. So you could use different words for the level of steepness, right? If it just goes up a little bit, what could you say? Barely increased, right? You could add some adjectives. Incline. All right, so what are some words for down? Decrease. Decline. What if we were talking about weight? Fall or loss? What if it goes down at a big amount?
Plummet.
Right? Like there are more words than the ones we're just writing. These are just basic ideas. What would a word for flat mean?
Same.
Steady. Depending on what it looks like, right? If you're measuring speed and it's steady, that would be flat. Averaged. What was the other one that I heard? Same. You could pause. You could remain. You could be holding. Then, after you divide it into your up, your down, your flat, you're going to match the sections to words. And here's the big one. Read the labels. Because, unfortunately, I mark a lot of relationships, stories that you write. I mark a lot of them incorrect because people don't read the labels. They're talking to me all about how, Sally's speed is increasing, then she remains the same, and then Sally sees a police officer, so she slams on her brakes and comes to a constant speed at the speed limit. All about this stuff. And then you read the labels and it's about hair growth. Well, that doesn't work. So you have to read those labels. All right, now, this is going to get glued on page 29. I'm going to glue after we talk about it. But this is going to be about modeling. This is going to be the actual practice. And I'm going to zoom in. And it says, a relationship between variables is often shown as a continuous graph. Study the segments of the continuous graph below and the common phrases that describe each of them. So I've given you even more vocabulary that you could talk about. Right? But if I was going to write a story about this, the first thing that's missing is I would need labels. So if this was time and height, and I was talking about, Sally climbed the surface of a rock wall, and then on her hike there was a gentle decrease, and soon she came to a point that was uneven and full of ledges that she had to ascend, where she reached a plateau until finally climbing to the peak of the hill,
And then she slid down.
where she rappelled down to a jagged rock face until she finally reached the bottom. But it would look different if I was talking about speed, right? If it was changed from height to speed, I would talk about how you quickly accelerated and then slowed down a little bit. And then you were chased, so you started sprinting at irregular, right? I don't know, but it depends on what your labels are. So let's talk. Look at this one. Number 1, give 2 phrases that could describe this graph. How could you describe this graph? Yes, I get that it's increasing, but how? What could you say?
uneven.
This one right here?
Oh, that one there.
Slowly accelerated. Perfect. What else could you say? Steady growth. Gradually climbed. Could you sketch a graph that shows the speed of a car decreased dramatically, then remained constant? So in order to decrease, I have to not start at 0. I'm going to decrease dramatically, and then I'm going to remain constant. Says, write the letter of the description that best matches each graph. A baby lost a little bit of weight, then gained weight slowly. A baby gained weight at a rapid pace. A baby gained weight at an uneven pace, then maintained a constant weight. So you have 1 graph, 2 graph, 3 graph. And you're labeling A, B, and C. A, which one is A? A baby lost a little bit of weight, then gained weight slowly. B, a baby gained weight at a rapid pace. And C, a baby gained weight at an uneven pace, then maintained a constant pace. So if you're confused, you split it up. This to this. This to this. Or this. So this has 2 sections, this has 2 sections, and this has 1 section. What does this show? And this show? Gained weight at an uneven pace, and then maintained. Maintained means flat, a constant weight. So C. Then decreased, and then increased. A baby lost, decrease, then gained, increase. And a baby gained weight at a rapid pace.